AV Blocks Lecture 2, Mobitz 1 second degree AV block, also known as Winkenbach. Our module objectives include defining Mobitz 1 second degree AV block, also known as Winkenbach. We're going to list the diagnostic criteria for a Mobitz 1 second degree AV block, and we're going to identify a Mobitz 1 second degree AV block by utilizing the rules of ECG interpretation. Second-degree AV blocks are characterized by both the presence of P waves and intermittently dropped QRS complexes. Grouping is a major characteristic of this block, and usually there's only one dropped QRS complex for each grouping. There's two main types of second-degree AV block, Mobitz 1 or Winkenbach, and Mobitz 2. There's two minor types, a 2-to-1 or untypable, and a high-grade or advanced. In this lecture, we're only going to discuss Mobitz 1 or Winkenbach. We'll have additional lectures that describe the other types. So having an understanding of conduction ratios versus blocks. When we use the word conduction, we refer to the ratio of P waves that conduct to the ventricles. A 3-to-2 conduction ratio means that in a grouping, there are 3 P waves, 2 of which conduct normally to the ventricles. This creates a P wave that is not followed by a QRS complex. When we use the word block, we are comparing the number of P waves in a group and the number of P waves that have been blocked. 3-to-2 block means that in a grouping there are 3 P waves and 2 P waves are blocked from reaching the ventricles. The drop QRS complex in all types of second-degree AV blocks typically provides a natural barrier for the eye that gives the complexes the appearance of being grouped. The regular empty space created on the rhythm strip by the drop QRS complex provides a natural break in the rhythm, which is very obvious to the naked eye. Since the drop beats typically occur fairly frequently, the empty spaces make it look like the complexes come in groups. So what's our criteria for a Mobitz 1 second degree AV block, or Winkenbach? The PR interval progressively lengthens until a P wave is eventually blocked. The shortest PRI is the one immediately following the drop beat. The longest PRI is the one immediately before the drop beat. The largest incremental change in the PR interval occurs between the first and second PR intervals in a group. The R to R intervals progressively shorten until a QRS complex is dropped. This is going to give it an irregular pattern. The interval, including the drop P wave, is less than the sum of the 2 P to P intervals. The pattern is repetitive throughout the duration of the rhythm, and the impulse does not reach the ventricles. Therefore, ventricular contraction does not occur when you have your dropped beat. The ventricular rhythm is irregular. The atrial rhythm remains regular because the atrial rate will continue to beat, and even if the AV node doesn't conduct that beat, the atrial will continue. This is also referred to as the Winkenbach phenomenon, and it can be caused by an abnormal conduction of impulses at the AV node and precipitated by AV node ischemia, digitalis therapy, or increased vagal tone. The Winkenbach phenomenon can occur with P waves that originate in the sinus node, the ectopic atrial tissue, or the AV junction itself. As the supraventricular impulses reach the AV node, the first complex after the pause finds the node normally or near normally, ready to receive and conduct it. The first supraventricular impulse is conducted without difficulty because the AV node is set to receive it. It easily makes it to the trigger zone and fires a ventricular depolarization wave. As the first complex traverses the AV node, it leaves the node a little more refractory and a little less ready to receive the next impulse. This is reflected as a delay in transmitting the second impulse to the ventricles. The PRI temporarily lengthens for the second complex. As the second impulse goes through the AV node, it will in turn cause further refractoriness that will make the delay even longer for the third supraventricular impulse. This prolongs the PR interval even further during the third complex. This process of delay leading to further delay continues until eventually the refractoriness and delay in this AV node reaches a point at which conduction completely fails. This will be represented on the ECG strip as a P wave with a dropped QRS complex. The time supplied by the blocked impulse allows the AV node to reset, and so the next P wave will begin the whole process over again. The AV node is best able to receive a new impulse immediately after the drop beat. So you'll have the shortest PR interval will be your first beat. Your longest PR interval will be the conduction that's right before the dropped beat. And your largest incremental change in the PR interval occurs between the first and second PRIs. So let's look at a couple of rules. The atrial rate is unaffected. The ventricular rate is usually slower than atrial. So you'll need to get an atrial rate and a ventricular rate. The atrial rhythm is regular and the ventricular rhythm is irregular. So there's a disruption in the R to R. There should be a P wave before each QRS, but not every QRS is going to have... There should be a P wave before each QRS, but not every P wave is going to have a QRS. What is characteristic of a second degree AV block type 1 is that it has a progressively widening PRI until the QRS is not conducted. So progressively prolonging PRI until you have a dropped beat. You'll still have a P wave with the drop beat, but the QRS will not be conducted. And all the QRSs should look the same, and they should be less than 0.12 seconds. So here are some examples. This is a 3-to-2 conduction. You have 3 P waves, but you only have 2 that are conducted through to the ventricles. Now note you have what appears to be a normal PRI, but then it's widening and then it drops. A normal PRI, a widening, and then it drops. This is a 4-to-3. You've got 4 P waves, but only 3 QRS complexes. Again, widening, 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 and drops. And this is a variable conduction. So you can have a P wave that has a normal PRI and a drop beat, P wave, then a prolonged PRI, then a drop beat, and it can repeat or it will be variable in its conduction. So the key points to remember about a second degree heart block is that the AV node is almost like a bouncer. Think of the AV node as a bouncer trying to let you into the club. The first time the P wave tries to get into the club, it lets it on in. Second time, it says, hey, you got to wait here just a moment, but then it lets it on in. The third time, if it's like a 4-to-3 conduction, the third time says, hey, you've got to wait even longer, but now you can get into the club. The fourth time you try to go into the club, or the P wave tries to go into the club, the bouncer says, no, you cannot, and you get turned away. And then this pattern starts all over again. You've got a normal PRI, but it's getting longer, and then it's gone. The QRS complex is gone, and this pattern starts over again. Here's another example. You've got a normal PRI, it's getting longer, and then it's dropped. So you've got a 3-to-2 conduction here. This one, you've got a normal PRI, it's getting very long, it's getting even longer, it's even longer, and now it drops. So the clinical significance of second degree AV block, it's usually transient in nature and often refers back to the normal rhythm without treatment. It's usually a pretty benign rhythm, but the thing that we're concerned about is that each AV block could progress to the next higher AV block. If the pattern demonstrates a rapid rate and frequently drop beats, you may have cardiac output that is compromised and you may start seeing signs of decreased perfusion. You must be alert to the possibility of advancing degrees of heart blocks.